Hello all of you. Today I will discuss about the gametogenesis. Gametogenesis means formation of gametes. In the male it is known as spermatogenesis, means formation of sperms. In female this process is known as oogenesis, means formation of ovum. So formation of gamete is known as gametogenesis. And it begins with the primordial germ cells, PGC. PGC means primordial germ cells, which are present in the embryonic life, in the developing yolk sac. First, this PGC formed in the epiblast. Epiblast or ectoderm, this is the germ layer, and from that epiblast it migrates into the yolk sac, and from that yolk sac it migrates into the developing gonad. In the male, that developing gonad is known as testis. In the female, that developing gonad is known as ovary. So first I will discuss about the spermatogenesis, means formation of sperm from the PGC. So PGC stored in the seminiferous tubules of the testis, and this process begins at the time of the puberty. First, there are so many mitotic division takes place in the PGC, in the testis of males, and from the PGC the cells formed are spermatogonia. So first cell from the PGC, primordial germ cell, we have the spermatogonia by the repeated mitotic divisions, and this cell contains the diploid number of chromosome, means 46 number of the chromosome. In the case of the male, the chromosome number is 44 plus XY. And again there is mitosis. At the time of the puberty this process takes place, and by the help of the mitosis there is increase the number of the spermatogonia. So now we have many more spermatogonia. As their size becomes enlarged, these spermatogonia now known as primary spermatocyte. So here I am showing you the development of one primary spermatocyte, although there are formation of so many primary spermatocytes from the spermatogonia with the help of mitosis. When mitosis happens, so there is formation of the two daughter cells from one parent cell. So this one arrow is showing there will be more daughter cells. So I am showing you the development from the one primary spermatocyte. And the next division that takes place in that primary spermatocyte is meiotic division. And this is the first meiotic division, as it is a reductional division. So there will be half the number of chromosome forms from this cell. As this is a reductional division, so the chromosome number will become half. There is 46 number of the chromosome. So with the help of the meiosis, there is formation of the two cells. And in each cell there is the half chromosomal number as of the parent cell. And these cells are known as secondary spermatocyte, and the equal distribution of the cytoplasm and the chromosome in each cell. And here in the box I have drawn a cell in which I am showing you the chromosome which is distributed in the secondary spermatocyte, and this chromosome has two sister chromatids in each chromosome. So in this case, in the first meiotic division, there is no splitting of the centromere, means the chromosome here is in the form of the two sister chromatid. After that there will be the meiosis second. In the meiosis second, now there will be the splitting of the centromere, and the two sister chromatids separate and enters into the two different cells. And in the meiosis second, there is a formation of the two cells from one cell, but the chromosome number is same. Only the genetic amount or material becomes half, as there is the splitting of the centromere. So there will be chromosome with one sister chromatid in each cell, and the chromosome number will be same as of the parent cell. So this meiosis second is same as of mitosis, and eventually there is formation of the four spermatids, as these are the rounded structures. So there are so many changes takes place in that spermatids, and this rounded structures transforms into a sperm with a head, neck, body and tail. There will be some structures formed in these sperms, that will be head, neck, body and tail, and this process which is transformation of spermatid into the sperm, it is known as spermiogenesis, means formation of sperm. And from PGC to spermatid, this process is known as spermatogenesis. It is a very simple process in which this 2N cell, the spermatogonia, changes into the 4 sperm. But this oogenesis is a complex procedure. This full procedure begins at the time of puberty, and all these cells are present in the seminiferous tubules of the testis. Now I am showing you the seminiferous tubules of the testis. So here are the seminiferous tubule of the testis. This is the structure of the testis, and this is the seminiferous tubule, and in each tubule there are spermatogenesis. There is the process of spermatogenesis takes place, in which all these cells are present. Means in one seminiferous tubule there are so many seminiferous tubules here. In each seminiferous tubule there are spermatogonia, primary spermatocytes, secondary spermatocytes, spermatids, and sperms are present. So this is the structure of the seminiferous tubule. Now I am moving towards the oogenesis. This oogenesis begins before the birth. The same procedure from the PGC, means the primordial germ cells, and these first migrates from the yolk sac to the genital ridge. From the genital ridge there will be the development of the ovary. In the cortex part of the ovary, this process starts, in which first there will be mitosis in the PGC and the formation of oogonia. In the case of the male, here it is known as spermatogonia. In the case of the female, it is known as oogonia, and the number of chromosomes is here XX. And again there will be mitosis, and from one oogonia there will be formation of the primary oocyte. But the next development stops over here. So this is the first arrested phase of the oogenesis before birth. So all of the primary oocytes present in the cortex of the ovary. The rest of the division starts at the time of the puberty, means with the age of 11, 12 and 13 years of the age, the rest of the process starts. And from that primary oocyte, there is meiotic first division occurs in this primary oocyte, and there is formation of the 2 cells. And these 2 cells are not similar in the size. One cell is larger as compared to this cell. This cell is smaller because of the unequal distribution of the cytoplasm, and this small cell is known as polar body, and the larger cell is known as secondary oocyte. This meiotic division starts from here, but this meiotic division does not complete before birth. This meiotic division will complete only at the time of the puberty, means at the time of the ovulation. And from one cell there are formation of the 2 cells. As this is a reductional division, so there will be the half of the number of chromosome. Now there will be secondary meiotic division just before the ovulation. Now again this division will not complete over here, and this is the second arrested part or phase of the oogenesis. First before birth and second before ovulation. Now it enters in the meiotic second division, but this division does not complete. It depends upon fertilization. So this secondary oocyte released from the ovary, and this is known as ovulation. So at the time of the ovulation, the secondary oocyte released from the ovary. If fertilization occurs, only then there is completion of the meiotic second division, and from this secondary oocyte again 2 unequal sized cells are formed. The one large cell is known as ovum, and the smaller cell is known as polar body. This will degenerate. These 2 polar bodies will again degenerate. So from one primary oocyte we will have only one germ cell, that is ovum. But in the case of the spermatogenesis, from one primary spermatocyte we have 4 spermatids, and this begins at the time of the puberty, and there is no arrest in this full procedure, but there are 2 arrests in this oogenesis. First before birth, and second just at the time of the ovulation. If fertilization does not occur, so this secondary oocyte degenerate without completion of the meiotic second division. So there is no formation of the ovum. Ovum only form if there is a fertilization occurs. So this is all about the spermatogenesis and oogenesis. Thank you.